question I was asked was 2013 question 1. Again, I'm going to do the same theory parts first and then a separate video for the calculation. So there's an awful lot of reading in the first paragraph, so I'm kind of just going to skip on here to the actual solutions. So why it is important to avoid trapping air bubbles each time the stopper was inserted into the sample bottle and when using the dropper. The reason why is because it would increase the dissolved oxygen concentration. Now again, there's a few ways in which you can state that, so that's not the only answer there if you just have a look at the marking scheme. B then, we're asked to identify compound A. So compound A, we're told, is that in an experiment to measure the dissolved oxygen concentration of a river water sample, a small amount of a concentrated solution of compound A followed by a small amount of concentrated alkaline potassium iodide were added. You need to know the two additions. The first addition is concentrated. Now the concentrated isn't necessary here because you're told it is in the question a concentrated solution of compound A. So it's concentrated manganese sulfate, okay, and that's always followed by concentrated alkaline potassium iodide. C, what was observed on addition of the concentrated sulfuric acid followed by the mixing, okay, so a brown solution, okay. So remember, we have our brown precipitate when I add in my manganese sulfate and my alkaline potassium iodide. So that gives me the brown precipitate, okay, but when I add in my concentrated sulfuric acid, that precipitate redissolves and I left with a brown colour or solution. So you will not get your marks there for brown precipitate because the brown precipitate at this stage has redissolved to give me my brown coloured solution. Part D then is to describe how the burette was rinsed and filled for use in these titrations. Again, I'm not going to go into detail on that. So rinse with deionized water, then with the solution it is to contain. So that's how it was rinsed. So you have to have those 2 points there to get your 6 marks. And then you're looking there at clamp vertically, using a funnel, add the solution to above the graduation mark, remove the funnel, adjust the tap, ensuring the area below the tap is filled until the bottom of the meniscus rests on the graduation mark. So any 3 there gets you your marks. Part E then, name the indicator used in this titration, okay, for BOD it's starch. Then you're asked to calculate, and I'll come to part F in a minute, so I'll just skip that for now. G, what conclusion should have been reached had a white precipitate been observed instead of the brown precipitate? That means there is no dissolved oxygen present, okay? And if that is the case, you have to go back and dilute the sample, okay? Kits designed for use in the field allow the dissolved oxygen concentration to be measured immediately, and you're asked why is it important to measure it immediately. The reason why is to prevent biochemical reactions, so the likes there of your photosynthesis, respiration, etc. Okay, any kind of those metabolic reactions can occur because obviously there is still microorganisms in the water.